Today we will learn about how to make a chassis in a short period of time. How to make and what will be the procedure if we are design using the SolidWorks software. How it will be easy, effectively, and efficiently. Before designing, just know about the software and about the chassis. Let's see. The today's topic is electric vehicle chassis design. And see, so first know about the SolidWorks software. The SolidWorks software is a multi-platform CAD, CAM, and CAE software. That CAD is a computer-aided designing, and CA is a computer-aided engineering. And now the latest version has added some CAM, computer-aided manufacturing, which will be by the help of software we can design, analysis, and manufacturing as well. So that's why it is a multi-pad platform. CAD, you can add the CAM and CAE commercial software. Next point says that developed this software developed by French company Dassault System. That every software having a developer that develop who developed this French companies are named as a Dassault System. And this next point, that SolidWorks is a cornerstone of the Dassault System PLM software suite, and which is used to generate the CAD model in this assignment. So this is using as a CAD model in this using this software. And next we are going for the next slide. That says that next point says that the SolidWorks started as an in-house development by MIT graduate John Strick, that time developed as SolidWorks Corporation in 1993. In the year of 1993, one of the MIT graduate just pass out and just graduate student is named as a John, and who is doing like a in-house development, that MIT graduate. So one of the graduate students making this software, designing this software, and on which date of in the year of 1993. And after 2 years, the Dagger system took over to develop this SolidWorks under its design floor. Means uh, some like our version of our mobile, each Android version, it will be uh, developed year to year, and some way month to month. Then these are the developing our softwares of our mobile phone. So it will be same way it will be reflected, and it will be developed. Each software, not only the SolidWorks software, each every software need to be updated. That is a developed SolidWorks under its design flow. Means it's developed, it's changes the versions and added some advantages that in our design floor. Now the latest version of the SolidWorks is 2020-21. 2021, the SolidWorks latest version is that is you can use the CAM, CAD, and CAE as well. Any kind of three workbenches you can use here in this SolidWorks software. Now, then the why we prefer this SolidWorks software. I personally suggest SolidWorks is a best software because my experience is a best for everything. You can design, you can this features, many features, then many workbenches are available that it will be easy to make easier to any kind of complicated profile. So that's why now the notable companies and notable automobile and the aerospace companies industries are using this SolidWorks software. That all of you heard about this notable company, that Volvo is a four-wheeler company. They're having cars, they're having JCB, all kinds of motors, and the Alta Motors, Toyota, Cherokee, Air Liquide, EAD Aerospace, Aviation Facilities, L&T, Tata Motors, AP Racing. That these are the notable company, and the AP Racing is a company which is used. So all of you know the expensive car is a Ferrari. The one of the expensive car Ferrari disc brake is designing, and the manufacturing company is a AP Racing. So now you can relate your now you can relate your uh, SolidWorks and your designing. You can enter into this notable companies. These are the notable company you can easily enter. So before that, you will have a good idea about our GD&T, geometrical dimensioning and tolerancing. Means that is a large topic is a GD&T, geometrical dimensioning and the tolerancing, material, production technology, all the material malleability and other things are you have to know about these small things, these little bit things you have to know before enter into the designing. So we are going for the one by one. Let's see. Then now this is all about our SolidWorks. Now we are just one line explain about our SolidWorks. If someone says that what is SolidWorks, then you can easily say SolidWorks is a mid-end software. Updated version, you can say SolidWorks is a high-end software and it is a feature-based software. I'm saying you that it has a lots of features and lots of different kinds of workbenches are available, so which will be used to enable to any kind of features you can make it. That's why it is a feature based software and parametric software, and that you can say it's a fully parametric. So fully parametric software means at any time anywhere you can change the parameter anytime. After doing a part design, solid modeling is completed, then you are assemble your profile, assemble your product part. Then at that time you realize that we need to modify some dimension to fit exact made for our product. So at that time you can change it. There will be interchangeability way you can use it. Now next is a fully associative software. Fully associative software means this point is part, assembly and the drafting. These three things are available, means solid modeling, assembly design and the drafting. These three workbenches. That different workbenches are there, but that file format is a part, assembly and the drafting way. This part will be if you change something in your part, then it will be automatically updated in your drafting sheet and assembly as well. The same way, if you change something in your assembly, then drafting or in a drafting sheet it will be automatically changed. That's why it is a fully associative software. Next last point is a SolidWorks is a BREP based software. That BREP means it stands for boundary representation based software. That boundary representation software means okay, boundary representation based software means you can use somewhere, you can use like a okay, so which type of use you can use like uh, somewhere we need to make some using points, no vertex points, edges of our profile in any surfaces, any planar, any irregular surfaces. If you make that, you can easily take any point, any edges or any faces, you will be able to make any kind of profile at any point. So that's why it is a boundary representation based software. This is all about our SolidWorks software. Now, I'm just going to explain about, if we know about the SolidWorks software, then just we are just making a chassis that just know about the what is the chassis and what will be the use and how it will be working. And see, the chassis is a main structural frame of an object, and all of you seen that uh, any kind of that may be a two-wheeler, that may be a four-wheeler, having some frame, that is a base frame that which you will be using, and that will be a strong component as a, if you say uh, एक घर के लिए पिलर की जैसे जरूरत पड़ती है, वैसे ही चेसी, the chassis is like a pillar, as like a pillar, means this chassis is a structural frame of an automobile, that which will be taking stress, strain, all the stress will be taking. And now the next point says that it contains all key components including suspension and drivetrain. Based on our structural frame or chassis, that will be a mm, that will be a strong component of our automobile, and any that you can say electric vehicle, the strong component of our electric vehicle. And that will be based on our chassis, that you can mount all the things like a suspension, drivetrain, you can mount, and that will be easily mount. Next point, there are five functions of chassis. That what are they? To provide an area for occupants and luggage, and offer safety to the occupants and the outside parties, and provide points for mounting of suspension and drivetrain, and provide a stiff framework linking all mounting points. Same thing is this. So based on our chassis, we can drive our you can drive train, you can include your suspension, everything you can include and you can mount easily. Then then the next point says that about chassis, the mounting of the component must be rigid. The mounting of the component must be rigid, as a large movement may causes components to interfere and thus not function intended. That your mounting component should be a rigid. Okay, now the next point says that this section covers the function of of a chassis, the different types of chassis. And now from the review, a suitable chassis for the electric vehicle will be designed. See, for these kind of functions, we have to modify, we have to create the different types of chassis. There are different kinds of chassis based on our structural and based on our body and different shape of our profile. Not even only a single chassis, there are different kinds of chassis are there. In electric vehicle, we are using two types of chassis design. So there are two types. What are they? The first one is a conventional chassis, that you can say another way, another name, a frame full chassis. In this type of chassis, the body is made as a separate unit and joined with ladder frame. That means it's a simple, that conventional chassis or full frame chassis, frame full chassis means uh, chassis is different, your body is different. That chassis will be taking a whole stress, strain, load, everything on a body. But in another way, the non-conventional and the frameless chassis, that which will be in this type of chassis, the ladder frame is absent and the body itself act as a frame. It support all the means in this non-conventional chassis, there is a no different in your no different, no separate part, no separate body. So that will be including one with acting as a one body as a frame. They're that will be a including body as a frame, and they will taking all the support in each of the body. So sometimes in an electric vehicle and any other vehicles having this type of way of using, they are using. I think SUV is a SUV using that frame body, that frameless chassis they are using. The most they are having both and having lots of example of the frameful chassis and the frameless chassis. If you enter into the chassis, there are different kinds of chassis. Just know about this little bit. There are two types of chassis. One is a frame, that frame full chassis, and second one is a frameless chassis. Frame full chassis means your chassis and your body is separate, and your non-conventional frameless means that body itself act as a frame. Now, See, now these are the different chassis, that this one is a frame and this one is a frameless. So here in this frame of chassis, that ladder type of profile. See, these are the ladder type of, these are the ladder types. And some kind, if you have this type of profiles, then you can say this as a joggle type of frame. And here you can see here the frameless, in the frameless you can see there is a no chassis, there is a no chassis, only it's taking a the small boxes like a to mounting your engine, any kind of engine part. Okay, so these are the difference between a frame and the frameless chassis. Now, see, in the ladder, so today we are using a ladder frame chassis. Why we are using the ladder frame chassis? Because of our India, we are using in in our budget, in our budget, that will be a easy to purchasing in any kind of people, um, any kind of people, that will be a, they can middle class family, they there may be a lower middle, upper middle, medium middle, so they can easily purchase uh, our vehicles. So how they can easily purchase, how? So we have to it will be a cost effective. How it will be cost effective, that we then it will be a production will be a gradually increasing, your selling will be gradually increasing. These are the kind of things we have to look into it. And now the leader frame chassis, so it's the very simple, it's a very simple. So how the ladder, sorry, the ladder frame consists of two longitudinal beams with multiple cross members joining to the beams. So as you can see in a previous slide, there is a two longitudinal beams are there, that in connected multiple as per your requirement. It's connected multiple members of the beam. And now it's very simple to make it, and it's very simple to manufacture it. And now it's it is versatile as allows virtually anybody's shape to be placed atop the chassis. And now the next point, the ladder frame chassis, as shown in the above figure, in the previous slide figure, is very durable due to its simplicity. Uh, जितना आसानी होगा बनाने के लिए, मैन्युफैक्चरिंग और प्रोडक्शन उतना ही इंक्रीज होगा आपके लिए, मतलब प्रोडक्शन एक गाड़ी बनाने के लिए आपको कम से कम टाइम होगा. So these are the kind of things we have to think, we have to do in our industries. So we are taking a simple ladder frame chassis. Now this is the golf cart, this is the electric vehicle golf cart. And now here it is using as a uh, mm, ladder frame chassis. And now what will be the condition if you making something, manufacturing something, design something, eh, how it will be effect? See, that chassis should be a lightweight, high dimensional stability. There should be a lightweight. Why? Because we are using electric vehicle. If we are using the electric vehicle, that low cost budget, and if you are using, then that your battery power will be low. Okay, and if your battery power is low, and if you give the maximum weight of a chassis, then what will happen? Your sitting capacity and your loading capacity, means your luggage and sitting capacity, will be decreased. So as per our requirement, as per our budget, we have to giving a lightweight, then it will be maintain lightweight vehicle. And it will be maintain our seating capacity, it will be maintain our luggage capacity, all the things will be maintained, that dimensional stability, excellent impact, stiffness, balance, and have aesthetic value suitable for use in campus conditions. These are the things we have to keep in your mind while we are designing, while we are manufacturing. And what will be the ground clearance? This is the ground clearance, field base clearance, and the sitting capacity should be how much, and the dimension, these are the dimensions. Okay, Now, see. So we are using, so this is my ladder type chassis. This is my ladder type chassis having some dimensions. So I'm just taking as per our requirement. I'm just taking a, that should be my lightweight and having some given some dimensions. And here is as you can see here, we are using some cross sections. We are using two different cross section, and this frame is total frame is a different cross section, and this frame is different cross section, and having some sheet metal inside of it and the top of this floor, and each dimension should be in centimeter. You can change all the units as per your requirement. You can change the units in our software part. Okay, and now as per our requirement, that chassis should be lightweight. These are the cross section. If we are giving fully solid, then chassis will be heavy. So our requirement, uh, that should be our lightweight. So that's why we are taking only the cross section and the pipe like a structures. Let's see how to enter into the software. Just a minute. Okay, now I'm just switching. It's very clear if I'm using this PDF of my chassis. So now this is my PDF. It's clearly, you can easily zoom in, zoom out. See, so this is my profile. So I have to make this one. So first I have to make how to easily in this SolidWorks software, how to easily make it. So I'm just making these profiles, this profiles, only these profiles to frame of this profile, base, only the base of the chassis. Okay, and that should be 164. The first one is a 164, and this distance is how much you can relate from the side view, the projection view. This one is 100. Okay, this one is 100 and 164. So now I'm just enter into my software part. Now this is my software, this is your graphical area, this is my um, this is my workbenches, we can switch into it, and this is my ribbon bar. And here I'm just taking a profile. So all of you have having some idea about the sketch. That sketch is just simply you can take a plane, but here today now I'm using for the chassis to easy to making our profile. Here I'm only using the 3D sketch that will be easy to make my profile. Let's see. So I'm using expand this one and just going to 3D sketch. Just go for this 3D sketch, and I'm using here it easy to just go for the front plane, and I'm just taking a profile that should be my rectangle. Okay, I'm taking a center rectangles, and it will be easy to give the dimensions. And now this is my rectangle, and I'm just giving one by one, giving the dimension. Now as you can see, it has rotated. It has rotated. If I'm going to this one, and now as you can see, it is moving like this. But my requirement that will be laying like this. So how it will be making? How it will be making? So I'm just giving the directions. I'm just giving the directions. Okay, again I'm just going to 3D sketch. Let's make a profile here. Okay, see the compass x, y and z, and I'm just doing the xy plane. Just take a profile like this. So just take a here, go for the front, and now this is my profile. Okay, after that I'm just giving only how it will be laying. This will be my in x-axis, and this line will be laying on a y-axis. So why I'm giving that? To restricting my degrees of freedom. So it will be laying in a this along the axis, and that along the axis should be my x-axis, and I'm just clicking, and here it is showing the x-axis, the make along the x-axis. Select, and now it has automatically taken. And now if I'm selecting this one, and that should be my y-axis. But no, it's not.
तुझे माँ आई है दिख गई आई है वो देख
Okay, now I'm using the same way I'm using here. This is my profile. This is my profile. So same way, the process is same. I have to give the along the direction how it will be laying. This should be my x-axis, and this should be laying on a y-axis. Now after after that, give the dimension. This should be how much? This should be my 40. Give the 40. And now after that, give the distance. It's given from here to here. I'm just taking this ace and this ace, this two entity, and select the value. How much? It's 60. 60 or 50. Let's check. It's a 50. You can give the 50 value. Give the 50. Enter. Now it has taken 50. Now it has fully constrained. And the unwanted entity inside of your profile just trimmed out. And go for the trim option, and I'm just trimming my unwanted entities here, 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 and here. This width, black color of maximum width of the lines are my boundary line. This is my frame. These are the axis line, and these are the axis line which will be taking a constraint. It will be making help. It will be a help for to making a fully constraint. Okay, no need to delete this one. If I'm deleting, then it will be uh, my fully constraint will be deleted. Now it has taken, and now let's see next what will be done doing. Then this line and this line, give the this line that should be starting point here to here is 40, and I'm just going to take that 40 lines and just go for the line and anywhere I'm just randomly taking a line, after that giving the direction, giving the dimensions. And now here I'm giving same way. Okay, give the dimensions. And now give the dimension from here to here is how much? It's 40. Give the 40. And here again this one and this one. That should be 40. Clear? Then this one is done. Next, which one? This line and this line. This line from here to here is 20. And I'm selecting again here to here is one more line in this side. Okay, give the dimensions. Here to here is how much? It's 20. It's 20. Give this side also. Give it 20. Clear? Then next, this one, these two lines are done. Then this line, and these two lines. Okay. And this line is how much? From here to here is 2.50. Let's take, and I'm using this one and randomly taking a line here. Okay, now this is my two lines, and this value is how much? 2.50 from here to here. Give it 2.50. Again, this one, this entity to this entity, how much? 2.50. Enter. Next, this line here and here we need to take. Go for the line. And if I'm going to take this one, this line to this line, then it will be a over constraint. Let's take, if I'm taking here to here, this line, it's showing a over constraint. And how to overcome? And here it is a y direction, and I'm just deleting my y direction. After deleting the y direction, it will be a clean, means it's a fully constraint. There will be no over constraint. Again, go for here and select this midpoint. It's laying exactly midpoint, so that's why it's not mentioned in a drafting sheet. Right click. Okay, here also mention the y direction, but this x laying in a x axis, so just go for to change this one x, this y, change, delete it. Okay, now it is fully constrained. Now this is my base is ready. See, this base is ready, and I have to make a profile like a 60 and 40 rectangle cross section. We have to make here 60 and 40 rectangle cross section on this base one only. Let's take, and now I'm just adding my profiles cross sections. Let's see. So now I'm just switching from the my sketcher to, I'm just exiting my sketcher, and now I'm just going to here weldment option. You can go through the features. You can extrude, after that you can shell it or thick it, you can use it, but there is a options you can give. You can give the value automatically corners will be specified as per your finishing profile. You can add it. So here we are having a weldment. Select the weldment. It will be easy. Using the weldment option, it's easy to create any kind of profile. There is a see here. I'm just using now. I'm in weldment workbench, and now I'm just using some structures. Let's see. I'm using the structural members. As you can see here, it is in the left side is showing that structural members, that structural mentions is standard. There are different kinds of inch, uh and inch standard, and so ISO standard. As an Indian, we are following the ISO standard. And next is a which type of requirement you have. Now if you expand this one type of, there are angle iron and the C channel, pipe, rectangle tube, SB beam, square tube, the different kinds of having. But our requirement is given is which one? 60-40 rectangle cross section. So just go for here, and that will be a rectangle. I'm selecting my rectangle tube. This is my rectangle tube, and after that give the size. Go for here, and you can 60-40. There is a 60-40, and this is 3.2 is the thickness of your uh, cross sections. Let's take this one. And after that, here is a group option. Now how to add the features in my features sketch profile, how to add the features. And so here I have a group option, so you can use the group. If I'm using individually, there will be we can't giving we can't maintain that corner specification. So if I'm giving the grouping in means only the rectangle, then it will be easy to smooth my corner and finishing my corner easily. As per your requirement, you can give any kind of corner specifications. So now I'm just using, just go for here. If I'm selecting this first member, this is my first member. I'm selecting this is my first. It will be taking a few seconds to generate your structural. And now this is my structural member. Now see, this is my structural member. See, it's taken from the center point. This is my center point. Okay. So here my requirement is, and my data given is only the starting point of a end of the edges. That means your profile, your structural member should be inner side of your profile. So no need to take a center point, so we have to change that one. So how to change that structural member to inner side of your profile? How to change? I'm just going to here to change the locate the profile. And here I'm using that locate profile, where we can change it, that locate profile. Here it is showing, see there is a both side, but this side is showing this type of, if I'm going to here, and it's not visible properly each of the points, each of the point. But here it's showing this type of dotted mark, and it's properly visible. So now I'm just changing my position of my feature, that should be my on end of this here. Now as you can see, it has inner side of my profile. So this is my sketch profile, and the structural has been added inner side of my inside of my profile. It's not a center. Clear? Then now I'm just giving all the profile end to end, that should be maintained, that end to end connection. How to maintain that one? So here at that time, using that group one, I'm just using that group members. So here I'm using, select this one. As you can see, it has taken that smooth connection between a adjacent line two adjacent line. And here it is showing that if you select this one, that it is showing that end emitter. Now it has the end emitter connection. As you can see, it's an end emitter connection. There is a no outside material, anything and nothing. So here, if I'm using this one, a end but, if I'm clicking the end but, now see the preview, and that will be added like this, end but like this. If I'm using here this one end but, and now as you can see, this will be a gap. Okay, so here but my requirement that should be a finishing. I'm not giving here. It will be these edges will be cutting my hand. That for the safety precaution, I'm just giving to smooth my corner. So that's why I'm using here that end emitter. Select this end emitter. Now it is smoothly connected. Now close it. It's very simple how to connect and how to make one. Just simple select your randomly select your group, and I'm just closing this one. Again, I'm just doing, see, select the structural member. After select the structural member, change the standard as per your requirement, change the requirement type of your, now my requirements rectangle tube 60/40 rectangle we need, and here the group member. Here we are having a group member. So you, now I'm just doing only a rectangle group members. Let's see. First one, this is my first group member. So it will be taking a few seconds to upload my features. Structural. Okay, now as you can see, this is taken from the center, exact center point of my structural member. So now my requirement is that should be on end to end, because my dimensions are given from end to end, not for here center to center. So that I'm just taking here to change my location. So here this dotted mark is showing in the last portion, it's not showing, but this end of the this edges it's showing properly. So now we are able to change the position of my sketch and my profile, the structural feature. So just scroll down, and here is setting, mirror profile, alignments, and lots of things are here. So now my requirement is locate that profile, select the locate thy profile, and now here it is showing like this. And now if I'm just doing, and this edges will be replaced from the center point to at this end of this profile. As you can see, now it's laying the end of the edge of this face. Clear? So now again, so it has selected my base one and the structural edges where it will be located. Now it's clear. Now it's done. Then just scroll down upper side, and now select this one. Same way, there will be not adding anything, nothing. Just click over here. And now I'm adding here my rectangle. This is my rectangle. Why I'm taking? Because of my two end connection meter will be easily creating. So that's why I'm taking here. So you can change the endometer condition here. If you're going for a setting, then it will be showing here. You can change it all the portion here. Else you can select this color mark individually corner. You can change it. So now it's a endometer. You can change this bot mark, and now as you can see, this bot mark, this hollow portion is here, this side. If you require this type of end but this one, and it has changed the position of that end connection. See, no, my requirement is for to giving a smooth corner. So go for this end to end, it will be connected. Now as you can see, it has connected end to end. Clear? Then I'm just going to add here same way. This is my straight rectangle here, and now it has connected same way. No need to change specially here. Each corner having a smooth corner or inside of my profile. This is my requirement. And now if I'm using this group one, if I'm doing here, no, it's not applicable. I'm selecting here, 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 here. It's not applicable to edit these sketches. So that means we have to create some new groups. So this is my one group, and again I'm just going to add the new group. Select the new group, and now I'm just adding my new group. Which one you can take a new group? I'm just taking this is my new group. First one, and same way we have to change the position, but because of my requirement is my given dimension is end of this one, so that profile the structural members should be inner side inside of a sketches. So go for this one as per your requirement. Somewhere it is given from the center or outer side of your sketch as per your requirement, but now my requirement is inside of my sketch. So now I have to change this one. Just scroll down and go for the locate profile. After the locate profile, it's showing here this one, and select here. Okay, now I'm clicking my connected angles. Just go for this one, select this two group and select here. Now this end meter corner connection here as well. Now this structural member has added inside of my profile. Again, it has connected. If I'm doing same way here, no, we are not able to add the structural member here. So again, we have to change the new group. Select the new group. I'm just changing that portion here. Again, we have to change this one. See, it's laying exact center point. So here, just click here, scroll down, locate the profile. So you can change here. Now it has edited. Same, just scroll down, and no need to individual to click each center point or relocate the position. If you take a single point initially, then no need to change. Just go for add some profile here, structural member here and here. The corners are smooth corner and profiles are inside of my sketch. Done. Then again I have to add a new group. Select the new group, and I'm just adding my profile here. As you can see, it's a little bit of upper side. See, this is my line and this is my line. Let's check to change the view. See, this structural member laying this way and this structural member like laying this way. So if I'm giving, then while I'm just giving my adding my sheet metal on this part, on this face, upper face, then this will be a upper side. So we need to direction to change the length as per my requirement. So here I'm just changing my direction here. This should be no issue. Then it you can change the relocate the position as well. I'm just giving the first one, relocate the position this point. Let's check here, inner side. Next, okay, it's not my requirement. Okay, let's see. So now I'm just giving to change it because it's a overlap. It will be overlap. Now I'm just giving a 90 degree. Then it will be rotating. Now it has rotating 90 degree. It's laying at the center point. So now my requirement is it will be not laying in a center point this side, because see, so that connection is a here from up, outer portion to this outer portion. So that should be my here. Same with this side be adding here. So I'm just changing my locate the position here this way. Again, I'm just giving this view, this view, and now as you can see, is there any overlap portion? No, it's a link properly. So according to your requirement, you can change the relocate the position. You can change the uh, alignment. You can give the rotation. You can give it. Next, I'm not giving here this portion. So if I'm giving here this one, and then it will be material, my structural member will be adding this side, but my requirement is there should be an inner side of my here. This should be a right side. So how to change that one? So no need to give second one, right click, expand and delete this one. Now it has deleted. So here I'm just clicking the new group again, select the new group. Again I'm just adding this one, and now see, same way it's showing, but our requirement should be, there should be, should not be overlap. So I'm just changing the relocate, the first changing the alignment, that should be a 90-degree. Click outside and give the position and locate the position. And now which side? See, okay, then I have to give these lines. Next, let's take, again I'm just going to add new group. So you can add new group here, select this one, and now as you can see, it has laying here like this. Let's check here. Okay, it's laying perfect. And now that should be inner side. So change the locate, locate here. Then same way, if I'm adding, then it will be adding this side. So again, I have to go for the new group. In this new group, I'm just adding here again to change the locate. That should be inner side. Okay, next. Which one? Left this one, this one. Okay. Now, again, I'm just going to again new group. The same way, that should be inner side of my sketch. Just select here, check it, laying position. Is it okay or not? Good. Then that laying of my profile should be inner side. Let's change it. Go for relocate on this side. Again, this one also go for the new group. Select this one. Same way, locate profile here. Done. Then only left these two things. And now how to add these two things? So simply again go for the new. The same way you can at a time add it at a center to center. No need to change this one. Now just check it. Is there any overlap portion? Yes. So we have to change the orientation. That should be my 90-degree. Now it's laying okay. Again I'm choosing this one. Now it has selected. Done. My base is done. Go for okay. So now this is my profile. After that, there is a one more thing is there here. This portion to add here. So first we have to add some thickness of my sheet metal. Okay. So I'm just going to switch again software. So which one is my top portion? Front. This is my front. So I'm taking here front one. So you can take any face and go to sketch. Simply create a sketch here, a rectangular. Else you can give the convert entities. This one, this one, this one, and this one. Okay. No need to take it again, give the dimension, nothing. Only I'm just giving to edges, then it will be automatically taken the profiles. And let's say exit workbench, and then we have to add some thickness of my sheet metal. Just switch to sheet metal, and here we are having a base planche. So select the base planche, and it's automatically taken the base, and that will be cover automatically how much that 2 mm, then 0.20 centimeter, and no need to change anything. That should be okay. Factor is okay. Only just go for okay. Very simple. Just go for the base plans and select your object and give the sheet metal thickness and done. And if there in any condition you require the direction, anything inner side of your profile or outer side, then you can easily click it. Again, I'm just showing you, just close this one. So already now it is unselect my profile. Now again, I'm just going to this one, the base flange, and it's not selected. So select this is which one is a profile. So this is my profile. And now after selecting a profile, it will be automatically taken your flange. That will be 0.2 centimeter means 2 mm thickness is there. The 2 mm thickness. See, this is our 2 mm thickness. So if I'm giving the reverse direction, then it will be like this. If I'm giving next reverse direction, then it will be inner side. So give the inner side of the thickness. Again, go for okay. See that inner side portion, that bottom portion is like looking like this, and the frame is showing, and bottom upper portion is cover of a sheet metal. If you make wants to convert entity, so while you are enter into the sketch and already you have a profile, so next profile no need to take that one. So you can directly, I'm just selecting the sketch option and I'm just going to convert entity. So you can select the any entities. Sorry. Okay, I'm selecting this face as a sketch plane. Okay. Now I'm just taking which one, that here this line I need. So again I have to take a line, give the dimension, everything. So already we have, so no need to click again a line go to the dimension, give the alignment, relation, nothing. So simply go for the convert entity and select the entity like this. Sorry, go for the convert entity. This will be a open, and select your convert entity and just go for OK. You can randomly select all if you require, just go for OK. And now it will be a convert entities. Okay, so this way you can add the convert entities. Go for simply select the sketch and select the entities. I will show you again the convert entities we have to make again. Okay, now this is my convert entities. And now, and hide all the sketches. Okay, let it be. Here we need to convert that one. Okay, now this surface has done. That's sheet metal. Let's check this one. So we have to create this one, and this should be a square of 2020 square cross section. So we have to create that profile. So here we are having a one line, second line,
Hello.
rectangles, and upper side a rectangle, the bigger one. Okay, so let's take that one. So that should be simply from here to here that we need to convert entity, create a line here, create a line here, and that we need to box. That box should be a 20 distance, and upper side profile is a 25, and the 112 distance of this rectangle. Let's do. Go for here, switch again, select the 3D sketch. Go for here, sketch option, expand, go to 3D sketch. Now it has selected 3D sketch again. I'm just clicking this front view, and now this is our profile. So again we have to, no need to create same this one. So I have to click this convert entities and select this profile, only the sketch entity, and any edges you can select, and that will be a converted entities. Go for here. And now this black color is a convert entity. Clear? Again, you can give the, okay. And now I'm just giving a line here from here to here. I think here having a line, no need to create a line. It will be saving your time if you make a convert entity. Go for the convert entity, this total line. Okay, clear? Again, here also we need one more line here. Okay, select a simple line. That should be laying position will be Y, and select this entity, and this convert entity should be a coincidence. Okay, now it has merged. And give the distance is how much? This is 100, give it 100. 100. Okay, and that should be here. If you take a construction line or axis line, join here. That should be x-axis. Now it has converted. Okay, now these two lines are exact position laying, and just go for the rotate. We have to create a box one. So for that box, Okay, we have to make a line, that pillar line. Just go for your pillar line, and here at this end of this corner, and select a line, right click, select, and select this line. Same way, give the alignment, and that alignment should be on Z axis. Select the Z axis. Now it's on the bottom portion. Just drag it opposite, and this line height should be 20. Give this one and give it 20. Again, we have to create one more line. Sorry, my line is on here, end of this and the middle portion of it. So now my requirement is that line should be laying on this face. Okay, again we have to delete this one. Delete it. Okay, so select this face, and I'm selecting this face. Go to this sketch option. That should be my front view. Okay, this side we have to create. Let's take a isometric view. Okay, like this. So I have to create this side. So just take this one, sketched one. Again, press Control 8 for the normal view. Again, we have to select. We have to select a profile. Go to this center rectangle. That should be a center rectangle here and here. Okay. Now this is my profile. And let's take this one. This is laying here. And just select this one entity edges, and this edges should be coincide. Done. Just give the dimension here. Just delete this one. Create a line here and give the dimension. Smart dimension that should be laying starting from here to here is how much? That is give it 50. Okay, exact 50. And this point and this point, that should be coincide. This point, press Control, this line. Coincidence. Now it's fully constrained profile. And give the length of it here. That should be 100. Okay, give the dimension, delete this dimension. Take a center line. Delete this one. Again, that should be symmetry about this axis. Press Control this one. Select these 2 points should be symmetric. And about this axis, select the symmetric and go for OK. And after that, give the dimension, then it will be a fully constant 100. Okay, next I have to create some profile using 3D. 3D sketch. Again, go for make a line same way. Now my profile is on here. Just select it and create a line. Right click, select same way, select the line. Align direction should be Z. And after that, give the length is how much? It's 20. Go for the smart dimension and give the 20. Enter. Now it has 20. Now it's a fully constraint. Okay, next. Select, create some pillar here. Click it, right click, select this profile and give it Z direction. Same way, this axis and this direction, give the dimension, it's 20. Again, make a line here. You can make a box from here. Select it, right click, select. Again, select this line and the Z direction. Same way, give here. That line should be 100. Sorry, 20. And one more last. This one, this point, right click, select. Same way, give the align direction. That should be a Z axis. Select this one, give the Z axis. And now give this direction. And give the distance. Is how much? It's 20. 20. Okay, done. Then make it the upper pillar, upper rectangle. So let's make it. Okay, only select you can line. End of this point. Which one is selected? Rectangle. No, I have to take a line. This end point, this end point. Okay. And select the unwanted means while I'm taking it, it's by default it has taken some relation. And again go for the line, select this one the same way. Don't be panic while it will be converted into over constraint. Just go for the delete and go for OK. Again select this one, right click, select. Again select this line and this line. Okay, now my box has been created. Then we have to make these profiles. The last one is left. At the end of this here, it will be taking some lines. So I'm just taking this one. Okay, I'm taking a center corner rectangle. Uncheck. Okay, I'm just deleting this sketch. Okay, now this is my profile. First, I'm just making this one, then we will doing the last one. Okay, just go for the weldment. First, we have to exit, then it will be activated here. Simple, same way, just go for here, select the structural member and select, I'm selecting this sketch. That should be, is it rectangle? No, my requirement is that should be my uh, square, square tube, and that should be 2020, 2020 square tube. Give the size 2020. Now it has changed. Okay, next, I'm just clicking this one. It's not selected. Where is my sketch? Okay, again go for the new group. Select this line. That should be laying inner side. So I'm just changing my locate position. Select that locate position. Here. Okay. So same way, I'm just selecting, go for the new group. Only it will be taking time to making a constraint, fully constrained profile. But after that, it will be very easy. It will be taking 2 to 3 minutes for the adding features. Okay, now it has added. Again, go for the new group. You can add this one, this one. Okay, before that, just take a position. That should be inner side, this one. Okay, same. Go for here, this one. And the endometer condition is there. And the last one, add new group again. Select this one, this one, this one, this one. And let's check it. Is if you require, then you can change the locate position. Is it required? Yes, I require. I'm just changing my locate position. Should be my corner. Okay, select here.
Okay, guys.
Okay, I have to delete again this one, last one, delete this group. Okay, again I have to add this group one. Okay, initially I have to change my locate. This one, locate portion. Now it has changed. See, then same way you can add there, here in this group 5, here, here, here. Okay, now as you can see, if I'm adding this two side, then it's taking outer side, but our requirement that should be inner side. So just delete last two of my sketch and that group 5. Delete this one, delete this one. Again, I have to create new group. Again, same way, just select this one. That should be laying on a inside of my sketch. Change the position at this point. And add this one. Okay, now it has added. Now it's left this line and upper rectangle. So just go for OK. Okay, this one also we need to change one. Last, edit this my square tube, right click, and here the edit feature. So this is my one, and I have to change that relocate one. Locate. And now it's showing properly. Okay, then no, I have to change this to one, because see, if I'm here, I'm taking this one, so that's why based on this line, this will be changed from outer side. So I have to change this one as well. So these small things we need to careful to add. Edit feature again. Which side group this one? Let's check this one. Which side? Which side? This one. So delete the second portion. Okay, now it has deleted. Again, I have to change this one as well. This group 5. Yes. Second one. This one. Okay. Delete this one. Change. And add new group. This one. Change the relocate position. locate position here. Okay, select this one because both are laying same way. Just selected. Now it has added. Okay, it's perfect. Okay, now I have to make a profile here at the top of here and one more line here. Okay, let's take. I'm taking this face, go to sketch option. This is the last. Go to simple sketch. First, you have to exit. Select your face. Sorry, this one also we need to change. That should be laying here in this inner side. Okay, one more things we have to edit. Then we have to go. Now it's perfectly adding. See? Okay, next. Sketch. Go to sketch. Select the face. This face as a plane. Go to this top view. Sorry, front view. And make a rectangle. And here I'm using the convert entities. This line, no. We have to create a rectangle that should be like this. Okay, this one. After that, give the dimension. That should be a 112. Okay, and this length is how much? It's, let's check. It's 25. 25. Done. The same way, I have to add here using this face. First, exit this one. One more sketch is left. So you can add. So at a time while I'm doing this line, at that time you can use one. Using this face, else it will be overlap. Go to sketch, Control 8 for the normal view. Make a line. Already we have a line there. So I'm just taking only this line here. Press Control 8. give the relation, then it will be a symmetry. Okay, so you can find, is it how much? This one is a 40, so that will be 60. It's a 30, 30. Give the distance is 30. This one as well, 30. Exit. Okay, now it's last. Go for the weldment. Select the structures, square tube 2020, and select this one. This one, this one, this one. Okay, now that end meter. Okay, good. Next, go for the new group and select this line and this line as well. And we have to change that condition. That condition should be laying inside of my sketch. Just change that position, profile, where this way. Same. Go for the second portion, change the condition, relocate. Here. Now done. And hide all the sketches. Now all the sketches are hide. Now this is our profile. Now it's the final result of my weldment of using the weldment electric vehicle four-wheeler chassis. So this way you can create only the, it will be taking time for the making a profile fully constrained. Else it will be taking a less time, relocate and the position, everything we have to change. Only these things. Else it's very simple, it's very easy to create any kind of profile this way. Clear? Now this is all about our SolidWorks chassis and how to make and how to use the sheet metal weldment in this SolidWorks software. So this is all about, and this is all about our electric vehicle chassis design using SolidWorks software.